this video is about graphing lines and zeros of a linear function. And so lines, you are familiar with lines and we see them everywhere. This is the slope-intercept form of a line. We're going to begin with this. The slope-intercept form of a line looks like this. It's y equals to mx plus b. And it's called the slope-intercept form because when you look at this form, you can see the slope. The slope is m, and it's always whatever's next to the x when it's in this form. So this is the slope, and this is the y-intercept. Okay. The y-intercept is the point where the x-coordinate is 0, and the y-coordinate is whatever the number is that touches the y-axis when it crosses through. The slope, we know, m is rise over run. You've heard of that. And it's the changes. This little triangle means, it's a delta symbol. It means the change in the y's over the change in the x's. It is y2 minus y1 over x2 minus x1, where you have 2 points on the graph, y1, x1, y1, and x2, y2. I think that you've seen that in previous courses. These are some equations that go with lines. One other equation that goes with line that is going to become important to us is called the point-slope form of a line. So the point-slope form of a line, this was the slope-intercept form, right? Slope-intercept form, this is the point-slope form. And it's y minus y1 is m times x minus x1, where 1 point on the line is this x1, y1, and the slope is m. And so it's called the point-slope form of a line because when you look at it, you can see 1 point on the line and you can also see the slope. So that's what this one is. And then here's the other formula we looked at. Slope is y2 minus y1 over x2 minus x1. So there's a few formulas that are important that we need to be familiar with. And now let's talk about the different kinds of lines that we can come across or will come across. Basically 4 types of lines. So here are some xy axes. I'm going to just draw a line. So here is a line. We could have a line that looks like this. We could have a line maybe that looks like this. We could have a line that looks like this perhaps. We could have a line that looks like this. These are basically the 4 types of lines that you might have. If you have a line that looks like this, it's going to try to take y equals mx plus b form right there. It can take that form. We would have to know the slope of the line, and we'd have to know the y-intercept of the line. And so I know you've seen this before, so I'm not going to go through every little detail about it, but I think that you've heard this before. Slopes that are going uphill, they have a positive slope. So the number m is going to be positive. So if we had to maybe guess, this is not accurate, exact or anything, but let's just guess. What would the slope of this line be? We could just pick some positive number. Let's let m equal to some positive number 2. And then let's say, well, where does it look like it's crossing the y-axis? So it's crossing here. So what if we said, what would we think that point is? Maybe we'll call it 0, 1. So we're just sort of pretending now. And this is one of the cases where if we were in the classroom together instead of just me here by myself, you guys would be picking these numbers instead of me, and we would go with whatever you chose, unless you chose a negative number for m, and I'm like, oh, that can't be right. We got to pick a positive number because it's increasing or whatever. But so since we can't be together, I'll just pick them. But this is what we would be doing. So let's just try to write the equation of this line. Y equals mx plus b. So we would say, okay, y equals 2. The equation of this line would be y equals 2m, which we chose to be 2, x plus b. And so we said it's crossing the y-axis here at 1, so we'd say plus 1. This is a possible equation of this line. Let's go to this guy. What's the difference in this line and this line? Well, the difference is the slope is going downhill. As we read this line from left to right, it's going down, which means that m is negative. It's got a negative slope. It's decreasing. M is negative, so let's choose a value for m here that is reasonable. Maybe we'll say it's -1. Okay, and let's see, where do we think it's crossing the y-axis? What point is this? Let's say that it's down here, it's crossing it, this is the point 0, -1/2. So if we chose that, that's fine. Let's write the equation of this line. Y equals to m -1 x plus b plus -1/2. This is a possible equation for this line right here. All right, well, let's go to this guy right here. This will try to take y equals mx plus b, so let's discuss what's happening here. Is the line going uphill like it was here with a positive slope? No, not really. Is it going downhill like it was here where it had a negative slope? No, not really. It is just staying the same. So at its very, very most basic place, a slope just basically means a tilt. Okay, if you don't think about very simplistically, it's just a tilt. So if something is not being tilted up, it's not being tilted down, it's just not being tilted, it has a slope of 0. It has no slope. It is flat. So horizontal lines have a slope of 0. They're not going up or down. So this line has a slope of 0. Okay, well, where does it look like it's crossing the y-axis? Well, this is on the positive side of the y-axis. So let's just say maybe this is the point 0,4. So let's write the equation of this line. Y equals mx, 0 times x plus b. But this slope, which is 0, kills the x term. So y equals to 4 would be the equation of this line. So let's take note of this. In general, if you have a horizontal line, the slope is 0, and so you don't see an x term. You only get y equals to a number. When you see y equals to a number, you know that you're looking at a flat line with no slope to it at all. Okay, I'm saving this one right here. This guy's in his own category. Why he's in his own category is the first 3 lines are functions. They all pass the vertical line test. Hello, Henry. Do you want to say hi? Look. Say hi. This is my puppy dog. Hello to everybody. Okay. Now. All right. So this one is not a function because it totally fails the vertical line test. If I were to pass the vertical line, can I make it touch more than once? I could make it touch an infinite amount of turns. So it fails miserably. This is not a function. That's one difference. So we can't talk about it being a function. The other thing is the slope here is undefined. It is so it is so steep. You couldn't walk on it. You couldn't climb it. You would fall off of it. And so the slope here is undefined. That is what's happening here for this guy. The slope is undefined. It cannot take the form y equals mx plus b like these 3 did. It cannot. So what form does it take? It takes the form x equals to something. X equals to something. And what does x equal to? Well, it depends on where it crosses the x-axis. So where does this cross the x-axis? Well, it's over here. Let's give this point a name. Maybe we'll call this -3, 0. If that is crossing the x-axis at -3, then the equation of this line will simply be x equals to -3. Okay, so this is our discussion about lines a little bit. Now we have a worksheet to look at to help us guide us through. So what I'd like us to do is go to the top of the page, and it says, graph the equation using the slope and the y-intercept, and I gave you a grid, and the numbers on these are 66 and 64. So let's have a look at these two. What if we have to graph this line right here? All right, y equals, or actually it says f of x equals to -2x plus 5. F of x and y are interchangeable, so we're just, if you don't want it to say f of x and you want it to say y, change it to say y in your mind or on your paper, it's fine. So I'm going to do that. I'm going to call it y equals to something. So here we go. This is 66, okay. Y equals to negative 2x plus 5. Okay. This is in the form y equals mx plus b. And so when it's in that form, I can say, well, what is the slope? The slope is whatever's next to the x. So m is negative 2. However, slope is rise over run. It's the change in the y motion over the change in the x motion. So I always want to look at it as a fraction. So if you have a whole number, put it over 1. So this is negative 2 over 1. This is the same thing as positive 2 over negative 1. This is and so the negative could be in the numerator or the denominator. Sometimes your book or your My Math Lab or people will write the negative right there in the middle, but it doesn't matter. These all mean that there's a slope of a negative 2 value. That's what that means. What is the y-intercept? Y equals mx plus b. The y-intercept is 5, so this is the point 0, 5. To graph a line, there's several ways to graph a line, but this is how I'm going to graph it, and I'd like you guys to learn this method. It's good, it's sophisticated. Go to the y-intercept, 0, 5, and mark a point. 1, 2, 3, 4, 5. Okay, there is one point we know on our line. Now, what we're going to do is we're going to move with our slope just to get a second point on our line. Well, our slope is negative 2. In order for it to be effective, put the negative either in the numerator or in the denominator. So I'm going to choose to look at it like this. Okay, if I look at it like that, my slope is saying negative 2, which is in the change in y, that's an up-down motion. Negative 2 means go down 2 over change in x is positive 1. Positive 1 means go to the right x because that's the positive motion for x. So to get to another point, I will travel down 2 and right 1. So from this point, I'll go down 2 and I'll go right 1 unit, and that will give me a point right there. That's a second point on my line. That's one option that you have. Here's another option that you have. You can interpret the slope of negative 2 to be 2 over negative 1. If we chose to go that route, this is what we do. From the y-intercept, we will go up 2, because that's a positive y motion, and left 1 unit, because that's a negative x motion. So if we went up 2, left 1, we would get this point right there. What this shows us is that you get two different points, but they land on the same line. And so what we were trying to do here was land on the same line, was to get a picture of this line. So it doesn't matter if we were to go interpret our slope either way. What we're going to get is this line right here. Okay, that's how we graph that line. So let's look at the next one. Y is 1/2 x plus 1. Y is 1/2 x plus 1. If we have to graph this line, we say, okay, what is the y-intercept? The y-intercept is 1, 0, 1. What is the slope? The slope is 1/2. Okay, so this means I will go up 1 and right 2. That's how you would interpret that slope. Even if you wanted to interpret this as a negative over a negative, which makes a positive, you can interpret the slope that way. You could say this is also negative 1 over negative 2, down 1, left 2. You could also do that. You don't have to, but it's an option that you have. First, find this point, 0, 1. Okay, there he is. Now interpret your slope. Either we're going to go up 1 and right 2. So let me put some more marks on my graph. Okay. We could go up 1 and right 2 and get this point right here. Or we can interpret it even this way. We could go down 1 and left 2. We could go down 1 and left 2 to get to another point here. We could go down 1 and left 2 to get, I'm sorry, my graph's a little messed up. Down 1 and left 2, negative 2, negative 1, to get to this point right here. And what you see is, it doesn't matter how you choose to interpret it, you will get the same line right there. So here we go. This will give us the same line. Now, I think I gave you grid marks on yours. Hopefully they're showing up. If they're not, just do what I did here to mark your own. So that's graphing a line. Now, your other worksheet I want you to try to do. I am not going to do this for you because I think you can do it after our discussion. But what I am going to do is make sure you can read the worksheet. Okay, so this is what I'm talking about. It's the matching one where you're matching all of these little lines and equations together, saying which graph is the graph of which line. And so I just want to make sure that you know what 1 through 10 say, because I had trouble reading my worksheet, and I want to make sure that you can see it. Okay, so let me just write down what those are, and you guys do that one on yourself. So let's just see here. Number 1 is y equals to 20. Number 2 is 5y equals to 2x plus 15. Okay, so my caution I would give you here is that you cannot see the slope, you cannot see the y-intercept, you can't see anything at this point, because this is not y equals to mx plus b. You need to divide both sides by 5 and get it in the form y equals to mx plus b before you proceed to try to pull out what the slope is in the y-intercept. Okay, so number 3, y is negative 1/3 x minus 4. Number 4, x is 5/3. Number 5 is y is negative x minus 2. Number 6 is y equals to 2x. Number 7 is y equals to negative 3. Number 8 is 3y is negative 4x. In this case, you should, again, solve for y. Divide both sides by 3 to get it in y equals mx plus b form. When you do that, you will just have an x term and you won't have a number. When you don't see a number and a line's in y equals mx plus b form, that means that the y-intercept is 0, 0. That's what that means. All right, number 9 is x equals to negative 10. And number 10 is y equals to x plus 7/2. So I just want you to make sure that you can at least see the equations correctly before you try to match the graphs. Okay, that's a good exercise for you guys to do. Now, what I want us to do next is something called find the zeros of the following functions. Mostly, I want you to learn what this word zero means. Zero in math means an x-intercept. An x-intercept. That's what a zero is. Sometimes we call zeros of a function x-intercepts or roots or solutions. They could be, all 4 of those are the names that we give those. So I want you to hear that and know that, because we will talk about that not just for lines, linear functions, but also for quadratic functions and other functions, especially as you go on in your math life. So right here, I have a few problems on the sheet that say find the zeros. If I were to ask you to find the zeros of this function, I want you to know that just means find the x-intercept. Okay? Solve for x when y is 0. That's what that means. How do you find a zero? So this is good to take note of. How to find a zero or an x-intercept. Let y equal to 0, solve for x. That is what you're supposed to do. Whenever they say find the zeros, let y equal 0, solve for x. So here we go. Number 1, A says 2x minus 3y is 8. We're supposed to find the zero. Let y be 0, 2x minus 3 times 0 equals 8, and solve for x. Negative 3 times 0 is 0. Solve for x by dividing by 2. X is 4. This is the 0. This is also the point 4, 0 when x is 4, y is 0. This is the x-intercept, 0 root solution. That is A. B, they give us f of x is negative 4x plus 3. Let y be 0, solve for x. Well, f of x is another name for y, so we're going to say let f of x be 0 is negative 4x plus 3. solve for x. Subtract 3, divide by negative 4. Negative 3 divided by negative 4 is a positive 3/4 is x. The 0 is x is 3/4, or when x is 3/4, y is 0. X-intercept, root, solution 0. All right. C. Y is 2. How are we going to solve for x if there is no x? Let's think about what this is. This is a horizontal line. Y equals to a number is a horizontal line. So let's look at this. Y is 1, 2. That's the graph of this. When is this line going to touch the x-axis? Never. It's up here at 2. It's not changing. It's always going to be at 2. It's never going to dip down and touch the x-axis. So in this situation, there is no x-intercept, or there are no zeros of this one. So that is C. What about D? X is equal to 5. Okay? Where is this? Now, this is not a function. So usually they don't use zero talk when they don't give you a function. But let's just say, where is it touching the x-axis? Let's figure this one out. X equals to 5. Where is that going to be? So, x equals to 5 would be, this is a vertical line. The slope is undefined, but it's a vertical line. And so here's x is 1, x is 2, x is 3, x is 4, x is 5. So this is the vertical line that crosses through x is 5. That's what the graph of this guy looks like. What would the 0 be? X is equal to 5 or 5, 0. For this graph, I can't call this a function because it fails the vertical line test. All right, lastly, E, find the zeros. F of x is negative 4/5 x plus 3. Find the zeros. Let y be 0. Solve for x. So we're going to say zeros here. Subtract 3. If I have to solve for x here, I'm going to kill my fraction. You can always do that by multiplying both sides by your denominator. So I multiply this side and this side by 5. What do I get? Well, if I have negative 3 is negative 4 over 5x, and I say times 5 over 1 times 5 over 1, what I get is a negative 15 is equal to negative 4x, because 5 goes into 5 once. I don't have a fraction anymore. Then I can see that I need to divide both sides by, negative 4. So x is 15 over 4. This is the 0, the x-intercept, the root, the solution. Okay, that's that part.